Hey guys, good morning. So welcome to class today. Today we are going to be starting chapter 5. The first section of chapter 5 is inverse and joint variation. So those are the notes we're going to go over today. So basically the first thing that we're going to do is review our direct variation. So for direct variation, we have the equation here, y equals k times x. So it looks very familiar to what you might remember back from Algebra 1 when you did direct variation, because it's really just like a form of y equals mx plus b, but it's a little bit more of a specified or a special form of it. So very similar to the slope, the constant is like a very special type of slope because it always goes through the origin. So no matter what k is, one of the points on your line will be 0, 0 because it will always go through the origin. So because of that, when you go to find slope, instead of doing y2 minus y1 and x2 minus x1, if one of your points is always going to be 0, 0, you don't have to do the y2 minus y1 and the x2 minus x1 because you could always pick 0, 0 for that second point. Therefore, you could take any other point on that line and just do the y divided by the x, that ratio. And that makes this slope something called a constant. So we use the letter k for it. I think the textbook we have now uses the letter or the variable a. So you'll see different variables being used to represent that constant. So basically, the equation is y equals k times x, which is really the same thing as y equals mx plus b, but the b is 0. And then we're going to refer to the slope as this letter k because it's called a constant. And the equation for that is just y over x. We don't have to do the whole long involved slope formula, y2 minus y1 over x2 minus x1, because, like I mentioned, one of the points will always be 0, 0, so it simplifies that process. And of course, when it graphs a line, it'll always pass through the origin, and it will not be horizontal or vertical because those would not follow the rest of the, what's the word I'm looking for? The rest of the criteria. Okay, so then we talk about inverse variation. So inverse variation, the relationship's a little bit different. So with direct variation, our relationship is always the y over the x will be one of the points on our line. So that's a constant relationship. Every point on the line, the y over the x will simplify to the same thing. It's the same ratio. With the inverse variation, this time our constant can always be divided by something, but divided by the x to get the y value. So when you're finding the constant, instead of dividing like we did for the direct variation where it was kind of like doing slope, this time to find the constant variation in the equation, you would multiply the x and the y. And if you think about it, that kind of makes sense because if you have this equation here, y equals k over x, and you want to get the k by itself, how would you do that? Well, you'd have to multiply x on both sides. And then on this side, the x's would cancel. You'd have your k by itself. And on the other side, you'd be left with x times y. So that's how you would get the k. In this case, it's going to graph something called a hyperbola. Okay, so first thing we want to do is be able to differentiate what type it is, right? So just as a little review, just so we can have it in front of our page here. So if we're looking at direct variation, just as a review from the top of the page there, we know that direct variation is y equals k times x. And then inverse variation is always going to be y equals k over x, like that. So essentially, to determine either one, you're going to want to make sure the y is by itself. And of course, if it doesn't fall into either of these categories, then you can just say that it's neither. All right, so let's take a look at the first one. So we have y equals 5 times x. So which of these two does it look like, direct or inverse? Well, this one's pretty obvious that it's going to be direct variation because it just follows that same pattern there, y equals k times x. In this case, the k would be 5. So your constant of variation for that equation would be 5. So that would basically act as your slope. For number 2, this one is a very straightforward inverse variation problem. You can see that it looks just like this equation that we have here for inverse variation, and the k would be 5 in that situation as well. So now if we go down to the next two, number 3, you have x plus 5. Well, these two, the relationships for direct is the constant multiplied by the x, and the relationship with the inverse is y equals the constant divided by the x. Neither of those have an addition, so this would be neither. It's neither direct or inverse variation. Now, number 4, we want to get the y by itself so that we can determine which type it is. So we would divide both sides of the equation by x. So that gives us y equals 5 over x. And now we can see it's the exact same thing that we had in number 2. So this would also qualify as inverse variation. Okay, so now looking at the data charts, that's another way to determine inverse variation. Now, like I said before, if you see 0, 0, that always would be a point on the line for direct variation, so there's no issue with that. None of these have 0, 0 anyway, but sometimes you'll see the relationship with all the other points, but obviously 0 divided by 0 is still 0, so that would be the one exception to finding that k. So basically, in order to determine whether x and y show direct variation or inverse variation or neither, and then based on what we find, we're going to write a model for that data. So the first thing we want to do is identify what is that constant. Now, for direct variation, since we know that the equation is the constant multiplied by the x, if we're solving for that k, remember it's just like doing slope, it's y over x. So let's find the constant doing it that way for number 1 and see if they're all the same. If they're the same, they're constant, and then you know it's direct variation. So if I were to do y divided by x for this first pair, that would be 15 over 3, which equals 5. Then for the second point, I would do 20 divided by 4, which also equals 5. And then the third set, 40 divided by 8, which also equals 5. So we can see that our k value equals 5, and it is direct variation. Now it says, if possible, write a model. And this is always the step that people tend to forget. So if you're writing a model, you're just now plugging in, you're writing the equation basically, and you're plugging that constant in because the constant doesn't change. That's why it's called a constant, but the x and the y represent a whole bunch of different points that would be part of that equation. So that's why they have to remain variables. So when we write the equation, it's going to just be y equals 5 times x, like that. So let's try the second one. So the second one, if I take my k, I'm going to have 12 divided by 4, which gives me 3. Then the next one, 8 divided by 6, that simplifies to 4/3 or 1.3 repeating. So right there we can stop because we know that this is not direct variation. So when you try to find that constant by dividing y over x, the first and the second one give you two different answers. Obviously it's not constant if they're different, so we know this is not direct variation. So then we can check for the inverse variation. So if we're going to do that, this time, remember inverse variation is your constant divided by your x. So to find the constant, you multiply x times y. So that's what we're going to do here. So this time, let's see what happens. So 4 times 12 equals 48. 6 times 8 equals 48. 2 times 24 equals 48. So all three of those ordered pairs for that set of data there, when you multiply the x and the y together, you get a constant value of 48. So our k would be 48 in this situation. This means that it's inverse variation because we got that k by multiplying the x and the y together. So now when we write the equation, we want y equals k over x, and the k was 48. So the equation would look like this: y equals 48 over x. So now we'll take a look at the third one. So now the third one, I'm going to check for direct variation first by doing the y over the x. So 6 over 2 is 3. 4 over 3 is 1.3 repeating. Obviously, 2 over 7 isn't going to work out either. So we know it's not direct. So then let's try the inverse variation. So this time we're going to multiply the x and the y together. So 2 times 6 equals 12. 3 times 4 equals 12. Looks good so far, but then 7 times 2 is 14, so it's not inverse variation either. So this would be neither direct or inverse variation. So when that happens, you don't have to write a model for it because there is no model. Okay. So now we're going to apply this to some problems, and I'm going to put a couple basic steps to follow because people like to rush to the answer sometimes and then they miss some important steps. So the first thing that we're going to do here is find k, and I would encourage you to write this down if you're writing your notes. The second thing you want to do is write the equation. And so remember, when we're writing the equation, because this section we're going to do right now is based on inverse variation, the equation is y equals k over x. Your x and your y are going to stay x and y. It's just that k that's going to be substituted for. And then 3, plug in and solve, and you'll see what I mean with that in a minute. And then of course to find k, since this is inverse variation, remember k is x times y. Okay, so taking a look here, it says use the given values to write an equation relating x and y. So the whole point here is that we want to write this equation. Okay, that's part A. After you write the equation, then part B says, then find y when x equals 3. Now, a lot of people will do part B because they'll do part A in their head and never write it down. But you need to write the equation if it says write the equation, because the equation, this is only one situation that we can use that equation to get an answer, but you want to write the equation because you may have to do it for multiple x values or y values or whatever. So you don't want to just like skip to the answer. So you want to make sure you do both. Okay, so to write the equation, you basically have to find your k. So we're going to do that first, find k. And after you find k, you're going to write the equation. And then you'll plug in and solve what's remaining. Okay, so the first thing we're going to do for this one is obviously find k. So now, because these are inverse variation, we know to find the k, you're just doing x times y. So this is very simple. 6 times 4, so we know k equals 24. So then the next thing we're going to do is write the equation. Remember, you're plugging in just that k value that we just got. So it's still going to be y equals, and then it's going to be whatever that number you got for k over x. So this is part A right there. So now for part B, you're doing step 3. So now it says find y when x equals 3. So you're using the equation that we just got in step 2, this one here, and you're going to plug in a 3 for the x. And then, of course, you could solve or simplify that. So then you're going to end up with just y equals 8. Okay, so for number 2, let's try that one. So for part A, you're going to first find the k value, and you're multiplying the x and the y that's given to you. So 72 times 1/2. So that k value is just really half of 72, which is 36. And then we can write the equation for that. Just y equals 36 over x. So really, once you get the answer to part 1, you have part 2 as well. Okay, then we want to do the second part, part B. Then find y when x equals 3. So we're just substituting in that 3 for the x and then solving it. 36 divided by 3 is 12. So that's our answer. And then finally, number 3. Okay, so for part A, first we're going to find the k value by multiplying the 18 and the 1/3. So 1/3 of 18 is 6. Then we can use that 6 to write the equation y equals k over x. So that would be y equals 6 over x. And then the third step, we're going to use that answer that we just got, which is 6, and we're going to divide it by the 3 that's given to us in the directions, and we get y equals 2. All right, any questions there? Let me know. Okay, so now let's do a word problem where this comes into play. Okay, so this question here says the volume of gas in a container varies inversely with the amount of pressure. A gas has volume 73 inches cubed at a pressure of 25 pounds per square inch. Write a model relating the volume and the pressure. Okay, so the first thing we want to do here is since it's inverse, I'm going to write down my inverse variation formula, right? So we know that it's y equals k over x, okay? And so this particular formula here, we want to relate these different items that we're talking about. So it says the volume varies inversely with the amount of pressure. So this means that we're doing the volume, which equals or varies inversely with the amount of pressure. So this is how we're going to kind of set it up. So just like we did on the last page, we're still going to find the k and then write the equation, and then we can substitute in whatever other numbers we want to continually solve for them, right? So we know that the volume here, first we have to find the k, right? So the k is still no different. So we know that to find the k, you're multiplying x and y. So in this case, to find the k, you're going to multiply the volume and the pressure that you already know kind of go together. Okay, so for us, we're going to find the k. Step 1, just like on the last page, it's telling us here a gas has a volume of 75 inches cubed at a pressure of 25 pounds per square inch. So we know that that volume and pressure goes together. So that's the x and the y that we can multiply. And when we multiply 75 and 25, we get 1,875. So now we can write that equation. I'm going to use this one here with the V for volume. The K we know is 1875, and then I'm going to just put P for pressure down here. If you use Y and X, it's the same thing. Okay, then part B of this problem, it says write a model relating volume and pressure. So I think we did that already. Yeah, so we're actually done. I thought it was going to ask us to plug in. Now, sometimes after you do that, it might say, so find the volume if the pressure is 50 pounds per square inch or something like that. And then you would have to use this model that we just wrote, and you'd have to then plug in numbers. And the reason why I always want to write this is because there could be 3 of them. It could say, find the volume at the following pressures, 50 pounds per square inch, 75 pounds per square inch, and 80 pounds per square inch or something like that. So you don't have to keep doing it over and over. You just write the equation once, and then you can just plug in as needed to get the different answers. Okay, so that's pretty much it for inverse variation. So now we're going to do joint variation. So joint variation occurs when a quantity varies directly. So it's very similar to direct variation, but instead of it varying directly to one other thing, it's varying directly to the product of 2 or more other quantities. So that's the difference. So instead of y equals k times x, like we did with the direct in the front of the notes, this time it's z equals k times x times y. And you could have a whole bunch of variables. It could be like, x, y, w, whatever. So it's 2 or more. And then, of course, to find the k, you would just have to divide both sides by whatever variables you have there that are not including the k. So in this case, it'd be x and y. If you had a third one, you'd divide by that also. Okay, so let's do those 3 steps we did with the inverse variation, but now we're going to do them with the joint variation. So again, the first step is going to be to find your k. And in this case, you're always going to find the k by taking whatever that z value is, the one that's by itself, and you're going to divide it by the product of whatever other values you have there. Okay, then for the second thing, you're going to write the equation. And just like we did on the other one, the only thing that's going to get substituted in is that constant or that k value. Everything else is going to remain a variable. You're only going to have a numerical value in for that constant. And then for number 3, then you would find or solve, I guess I can say. So plug in and solve. Okay, and then that can be done with whatever random values they give you for x and y, and then you can solve for z. Okay, so for part A, first thing we want to do is find that k value. And so we're going to take the z, which is 6, and we're going to divide it by the product of 3 times 8. So if you remember your PEMDAS, whenever you have something set up as a quotient, you'd have to simplify the numerator and the denominator separately before you can divide or simplify. So 3 times 8 is 24, and that leaves us with 1/4 for k. So now we would write our equation, z equals, we plug in that k value that we just got, and then just multiply it times x and y. So again, once you get the k, all you're doing is plugging in the k. Everything else remains a variable. The constant's the only number that you're going to put in. The x, the y, the z, whatever other variables you have, stay variables. Then for part B, it says, then find z when x equals -2 and y equals 4. So now we get to plug those numbers in. So this is for part B. So z equals, we already have that 1/4, but now we're plugging in a -2 for the x and a 4 for the y. So you're just going to multiply those 3 together. So 1/4 and the 4 are going to cancel, so we're just going to be left with that -2 for z. So now we're going to do the same process for number 2. So for part A, first we're going to find the k. So we're going to take that z value of 2. We're going to divide it by the product of x times y. So -12 times 4 is -48. And then that's going to simplify to -1/24. So now when you go to write that equation, don't forget the equation. That's what people always get wrong on quizzes and stuff like that. We write z equals, we plug in that -1/24 for our k, or our constant, and then times xy. That is the equation. And now we can use that equation to do part B. So we're going to just substitute in the x and the y that are given to us in the instructions. So -1/24 is the constant we found. That doesn't change. We're substituting in -2 for x, and we're substituting in 4 for y. So when you multiply those, 2 times 4 is 8. 8/24 is going to simplify to 1/3. And the negatives, of course, when you multiply, get canceled out. And that is how you write a joint variation equation and then use one to solve a problem. Okay, so we're going to do a couple more of these with the joint variation. This time, however, we're going to have some with fractions. So I would encourage you to leave it in fraction form. It might seem a little tricky at first, but sometimes they end up canceling themselves out in the end. So I would just leave it like that instead of trying to do a decimal, especially if it's a repeating decimal, then that might end up leaving you with an answer that's not actually correct. So be careful with that. So again, we're going to go through the same process we just did in the last two examples. So the first step, we're going to find the k by taking the z and dividing it by this product. Now, this is where some people are like, what? Because we have a fraction and a fraction, right? So this is how I'm going to do it old school, right? So 2/5 divided by, and this is -18, right? Now, if you remember, when you multiply fractions, right, you leave the first one, change the sign to multiplication, and then flip the second one, because now I can do this in my head. So it's 1/45, and it's a negative, okay? And you could do it on your calculator too, that's fine, but I would encourage you to leave the answer in fraction form or you have a really weird decimal. Okay, so now we're writing the equation. Z equals -1/45 times xy. And then finally, we're going to do that third step. So if I go back to the directions here, then find z when x is -2 and y is 4. So now when I multiply these, I'm going to have -8 over -45. The two negatives cancel out. And let's see, what does that simplify to? Just 8/45. That does not simplify. There we go. Okay, so let's do the last one. So first thing, we're going to find that k value. So we're going to take the z, which is 8, and then we're going to multiply the x and the y. So 5/6 and 3/10. So remember, when you multiply fractions, you multiply the two numerators. So you're going to have 15/60, which of course that simplifies to 1/4. And then if I'm really doing 8 divided by 1/4, that's really 8 times 4/1, which gets me a k of 32. And again, you can check all that on your calculator. So now we want to write the equation. Z equals 32xy. Everything remains a variable except for the constant, which was 32. And then now you can use that wonderful equation that we have there. We can substitute in the -2 for the x and the 4 for the y, multiply out those three values, and we would get -256. Okay, so writing an equation for the given relationship. So first thing we want to see is how is it varying? This one's going to vary directly and then inversely. Okay, this one says varies jointly. So basically the way I kind of think of it is I read it left to right and I kind of just put it in as it comes, right? So we know that direct, just from the beginning of our notes, if y varies directly with x, we're writing it as y equals k times x, right? So if v is varying directly with u, that's going to be v equals k times u. Now, if something is varying inversely, y is going to equal k over x. So basically what happens is anything that's varying directly with something, those somethings are just going to get multiplied to the k. Anything that's varying inversely is going to get divided or put into the denominator. So if v is varying directly with u, the u goes on the top with the k, and inversely with t, the t would go underneath of the k. So this is what your final answer would look like. V equals k times u over t. So let's try that with the next one. Now remember, joint variation is really the same thing as direct variation, but you just have more things being multiplied. So w varies jointly with t, u, and the cube of v. So w equals k times t, u, and v cubed. That's it. Okay, then the next one we have y varies jointly with x and z. So we know this one is y equals k times x z. That one's pretty basic, that part. But then it says, and inversely with. So remember, anything that's inversely is going to go where? On the bottom, right? So then we make this into a fraction, and it's inversely with the square of v, so then v squared is going to go on the bottom like that. All right, and that's it for today. This homework is not your homework. You guys will be doing the quizzes assignment that I put on there. It's just going to be a little bit easier to do that since we are remote right now. So, do the problems however you want, answer them on the quizzes, submit it through there. I can log on and see who did it. It's just an easier way to check it. We don't have to worry about everyone taking pictures and submitting them all different ways. If you have questions, as usual, feel free to send me a question on Remind. That's probably the easiest way to get to me, or I will be posting a few meetups in the afternoon. We're going to try that because I know some of you guys like to sleep in the morning, and hopefully that'll work out. So have a great day, and let me know if you need any help with anything. Bye.